Hi everyone, and today we want to talk about matrix multiplication. So in our past lectures we learned how to multiply a scalar with a matrix. But what if I want to multiply two matrices? Today we will see how to do that. So let's take a matrix A like this, and let's take another matrix B. Let's say 2, 3, 6 and 7, and I want to know what is A times B. This is the thing I want to know. So how to go about it? Well, before even we can talk about matrix multiplication, we need to define when matrix multiplication is possible. So there is a condition for matrix multiplication. And this condition is essential in order for the matrix multiplication to be defined. So let's take a matrix called M, which has the order M cross N, and let's take another matrix N of order N cross B. So the number of columns in N and the number of rows in N are equal. This is the case where matrix multiplication is possible. That is, for matrix multiplication to be well defined, you need this condition. And if you take a look at the example that we are going to look at in a few seconds, that this is a order 2 cross 2 and B is also a order 2 cross 2. So we can define our matrix multiplication. Now, okay, that was 2, 3, 6, 7. Alright. So let's write the product as C, which comes from the multiplication of A and B. And if we use the index notation, then for, let me erase that, it looks a bit similar. Okay, this is small c ij. The multiplication is defined through this equation. So this might seem a bit abstract and it's not clear that, okay, so this might seem a bit abstract because it's written in all symbols and that, but let's try to do it explicitly. Note that the elements coming from A is denoted as small a and elements coming from B is denoted as small b. And this k index is called a dummy index because it's getting summed over. And this I or j, these are called the live indices. That is, they are not getting summed over. So that's what we mean by live indices. So let's say I want to evaluate the, let's say C has the following form, and this element corresponds to 1, 1, right? So if I want to have C1, 1, how do I write this? I have to first, let's write the sum over k, put 1 instead of I, you write k, bk, and put 1. Now you sum over the k. So A 1, 1, B 1, 1 plus A 1, 2, B 2, 1. And if you look back, you can see the A11. Okay, let me just zoom out so that we can see the whole thing. Okay, so A11 is 1, B11 is 2. So let's write the first term. This is 1, this is 2, A12 is 0 and B21 is 6. So this is just 2. You can evaluate the other elements as well. For example, you say you want to evaluate C12, right? Again, you can put the I and j indices first and sum over. So let's do that. And if you expand this, that is, you write the sum explicitly, it becomes A11, B12, and A12, B22. A11 is 1 again, B12 is B12 is B12 is 3, A12 is 0, and B22 is 7. So this is just 3. So now if we write this C matrix, we already know how to evaluate each of the components, and if you just compute all these components, then you will have 2, 3, 6, 7. Notice that we took a very special matrix A that is known as the identity matrix. It actually does nothing. It's just it's equivalent to multiplying by 1. So this is the formal definition of matrix multiplication, and a thing to note that is, in general, this upper limit on this summation will depend on the n's. That is, if you consider two matrices capital M and capital N, and which has order of small m cross n, the upper limit on the summation will be will start from 1 and it will end on n. So if I had a, let's say, 3 cross 3 matrix, and I want to multiply with by another 3 cross 2 matrix, the summation would run from k equals to 1 to k equals to 3, and just like that. So this is the formal definition, but in general we can do things without referring to this sum. Let's say you have a matrix of 2 by 2, 1, 2, 0, 6. Let's take that, and note this is a 2 cross 2 matrix, and what we want to do is that we'll take another matrix called B, which has 2 rows but 1 columns now. Let's say this is 1, 0 for simplicity. This is 2 cross 1, and from these two numbers, that is the number of columns appearing in the first matrix and the number of rows appearing in the second matrix, you can immediately tell that AB will be a 2 cross 1 matrix. And how do we know this? Let's try to evaluate this multiplication first, and we'll see that this is coming automatically. So the first thing you need to do, you need to select this whole row and multiply it with the whole column, and this one will be multiplied with this one, plus this 2 will be multiplied with this 0, and you have to add them. So let's write it down explicitly. You have 1.1 plus 2.0, and the second row, take the second row and again multiply with the column. So again this will be 0.0.6. oh yeah, sorry, this is not 6, this is 0.1 and 6.0. if you then evaluate this, this is just 1 and this is just 0. Notice that we could evaluate AB, that is A was multiplied to B from the left hand side, but could we do the same for BA? The answer is no, because if you think of BA, then you have 1 0 multiplied with 1 2 0 6, right? But look at this again, this is a 2 cross 1 matrix and this is a 2 cross 2 matrix. You see the number of columns that B has is not the same as the number of rows A have. So this time BA is not defined, so we cannot do it. This is a important thing to notice. And now let's take another example of matrix multiplication. Oops. And now what we want to do, we want to say 1 2 3 0 1 0. I take a matrix of 2 rows and 3 columns, so this is a 2 cross 3 matrix. So in order for the matrix multiplication to be well defined, I need another matrix of the form 3 cross something over here. That won't matter, but I need to have this 3. That is, it should have 3 rows. So let's take a 3 cross 3 matrix. 1 0 1 1 0 0. I'm taking this 1 and 0 just for the sake of the calculation, so that things become really simplified when I multiply them. And let's take 4 5 and 0. So this is a 3 cross 3 matrix, and you can immediately guess that the resulting matrix will be a 2 cross 3 matrix. So how to multiply these things? Again, take this whole row multiplied with the first column. So you multiply 1 with 1, 2 with 1, 3 with 4, and then you add them, and that will give a single element. Let me write that down explicitly. So this one is 1.1 plus 2.1 plus 3.4. This is just one element. And how many times do you have to work with this first row of matrix A? That is, so how many times do you have to work with this? So how many times do you need to work with this row? Well, you have to look at how many columns are there. I have 3 columns over here, so I have to work with it 3 times. And the first time I use the first column. The second time I'll be using this first row and the second column. Let me denote this with another color. So again, you take this row, multiply each element of this row with each element of this column like this. 1 with 0, the first 0, that is the second element of the first row and the second column, then 2 with this 0 and 3 with this 5, and then you add them. So let's write it down. It will be 1.0, 2.0, 3.5. Again, we need to work another time because there is another column over here, and if you multiply it, 1.1 is 1, 1.1, then you do 2.0, and then you do 3.0. and we have another row after the row 1 2 3. Again the process is similar, so it will be 0.1 1.1 0.4. then you take this row again, multiply with the second column over here, so it will be 0.0 1.0 0.5, and lastly you take the third column and multiply with the row, that is taking this row first and multiply the elements of this row with the elements of this column. So if you do that, 0.1 1.0 then plus 0.0, and the and then you just need to evaluate the numbers over here. So this is the first thing, is this is your 1, this is a 2, this is a 12, so it's 15, and this is 0, this is also 0, and this is 15. And this is 3, this is 2, and this is 1. I mean, sorry, this is 0 because it has a 3 dotted with a 0. By dot I mean multiplication. This is also 0, and this is just 1. So this is 1, this is 0, this is 1, and this is 0. So this is just 1. And from here we can have just 1. Oh, sorry, it should be 0 because they are all multiplied with zeros. And finally you can see that this is also 0 because all these numbers are multiplied with 0. So you can see that this matrix has an order of 2 times 3, as guessed from the structures of the previous matrices, that is the matrices we want to multiply. So this is how you can do matrix multiplications. Hope you enjoyed it, and see you in the next lecture. Thank you.